Welcome to Bonhill Geography. Today we'll be looking at a fieldwork recap on the River Wharfe and Kettlewell. We'll explore how the river changes as it flows downstream. I'll take you through our methods, challenges and findings, providing a comprehensive look at our study. If you are not in my school, you could still find this useful for looking at how the model answers are structured. Let's get into it. Introduction. The River Wharfe was an ideal site for our study due to its accessibility and diverse range of physical characteristics. This allowed us to observe and measure various changes in the river's properties as we move downstream. The river's varying width, depth and flow rates provided a perfect natural laboratory for our investigation. Risk assessments and ethical considerations. Before we began our measurements, we conducted thorough risk assessments to ensure our safety. High flow rates posed a risk of slipping and falling, so we wore appropriate footwear and used safety ropes where necessary. Ironically, on this day, this is a video from our own experience, we obviously didn't go into the river. We also considered the environmental impact of our study, ensuring we left no trace and disturbed the natural habitat as little as possible. Ethical considerations including respecting private property and ensuring that our activities did not harm the local wildlife, which in this scenario was just birds and sheep. We measured the river's width, depth and velocity at 3 separate points downstream. Here's how we did it. Width measurement. Using a tape measure, we measured the width of the river from bank to bank. This straightforward method allowed us to get an accurate measurement of the river's span at each site. Depth measurement. We used a meter stick to measure the depth at 5 points across the width: 0%, 25%, 50%, 75% and 100%. This provided a detailed cross-sectional profile of the river, highlighting variations in depth and identifying any anomalies caused by large rocks or other obstacles. Velocity measurements. To measure the velocity, we used a high-tech technique. We timed a tennis ball floating over a 10-metre distance. This practical approach gave us a clear indication of the river's flow rate at each site. We repeated this measurement several times to ensure accuracy and consistency with our data set. But naturally, we encountered challenges. We faced several challenges during our fieldwork, which we'll talk about now. As we can see, access to the river was really difficult due to high flow rates, which made some areas unsafe to approach. There were large rocks on the riverbed, providing lots of anomalous data. These complicated our depth measurements. The river width also varied significantly within each measurement area, making it challenging to get consistent readings or provide a whole picture. So what did we actually find? We found that the average width, depth, velocity and discharge increased downstream, though the most significant changes are between sites 1 and 3, with less change between sites 1 and 2. Now we presented our data in 2 main ways. We plotted, using the example behind us, cross-sectional areas. We created cross-sectional diagrams of the river channel at each measurement point to visualize the changes in depth and width. These diagrams provided a clear visual representation of the river's profile, making it easier to compare against changes at different points. We also used a located bar chart. This was to show the changes in velocity at each point downstream. This helped us to identify different patterns and anomalies in the river's flow. The bar chart effectively summarized the velocity data, making it easy to spot trends and outliers. Let's briefly discuss the advantages and disadvantages of our data presentation methods. Firstly, let's look at the cross-sectional areas. The advantages. These diagrams provided a clear visual representation of the river's profile, making it easy to compare changes in depth and width at different points. They highlighted variations and anomalies such as areas of significant depth changes or the presence of large rocks. However, they can be time-consuming to create and don't capture all the complexities of the riverbed, especially with the large rocks causing those anomalies, so we might have inconsistent data. Now the located bar chart effectively showed our variations in velocity, allowing for quick identification of trends and outliers, meaning it was an accessible tool for presenting complex data in a clear and concise manner. By putting it onto our map, as our location significantly indicates, it meant that we could also see the change at each point. On the downside, it may oversimplify the data and not account for all the factors influencing that velocity, such as obstacles in the water. On quite a few of the days, this was an issue that we kept on facing. Additionally, the bar chart doesn't provide much detail about the river's physical characteristics, nowhere near to the extent of the cross-sectional diagrams. Solutions and improvements. To increase the reliability and accuracy of our data, we could make several improvements. These are important to note. Now, revisiting the site at different times to account for the variations in flow rates. This would help us to understand how the river's characteristics change under different conditions. We could also repeat width and depth measurements at each site to ensure consistency. Multiple measurements would help us to identify and correct any anomalies. Removing anomalous data where possible to improve the overall discharge calculations. This would provide a more accurate representation of the river's flow's dynamics. This is a summary of our data collection for all the data we collected in Leeds. Please do use this data if you are in my school, because this will be much easier for you to do so in the future. Do feel free to use mine for any other schools that are also using this data, but do make sure that you are referring to my case study. As a reminder, our title is Does the River Wharfe Change Downstream? Here's a quick summary of our main points that we have said. As a reminder, we looked at does the River Wharfe change downstream? Okay, so here are 2 6-mark questions. I'm going to highlight how important it is that you read the question properly. The first question is asking us about data presentation. The second question is asking us about data collection. You must make sure you underline or highlight that word within each of the areas. Now, sometimes these are open-ended, but they are normally asking you specifically either about your human or your physical fieldwork. Do not mix these up. What we've been over today is our physical fieldwork. Question 3 is very similar to question 4, but has been slightly changed without the word methods there for results and conclusions. Now, these are normally very open-ended. I would suggest you use the physical example for this, but again, that is up to you. Now, over the next 4 slides, we do have model answers. However, I'm going to ask you to make sure you are trying these questions before you go for it. Thank you for watching this fieldwork summary of Does the River Wharfe Change Downstream on Bonhill Geography. Catch you in the next video.